I'm Edward. I'm a machine learning engineer at Kung Fu AI, and I'm going to tell you everything you need to know about AI in 15 minutes. And yes, I am sitting in a closet right now because it sounds better. All right, AI/machine learning, which can be thought of as a part of data science, is anything that uses historical data to make a prediction. So I made a little plot here of the simplest AI model I could think of. It's called a nearest neighbors model. And every data point on this plot is a piece of meat that I've eaten. So when I ate the meat, I measured how stinky it was and wrote that down. I wrote down how many days it had been since I'd bought it. And then I wrote down whether or not it made me sick. Now I have a new piece of meat that I am about to eat. That's represented by this white point here. I know how stinky it is. I know its age. Is it going to make me sick? Well, I plotted on this graph. If most of the points that it's closest to are red, then I think it will make me sick. If most of them are green, it's not going to make me sick, hypothetically. So in this case, of the 3 points it's closest to, 2 are red and 1 is green. So I'm going to say this piece of meat will make me sick with a 2/3 probability, which is not really a perfect probability, but it's a better guess than nothing. Boom, we've made our first AI model. All right, so what could possibly go wrong with something that simple? And the answer is anything, because it depends what you use it for. It also depends on if you're correcting your data for any biases or things that you don't want in there. So this brings up the risk that's fundamental to all AI called misalignment, where the intended use case of a model doesn't match what actually happens. So let's say you have to read through 1,000 resumes a month and you want an AI model to automatically filter out the terrible ones and automatically highlight the great ones. That makes sense, right? So you take your historical data set of all the resumes you've ever reviewed, and you know whether or not each resume led to a hire. So you say, all right, well, the resumes that led to a hire, those are great resumes. But what happens if the person who worked here before you only hired dudes? Let's look at this in the data. So this is fake data, but pretend that it's not. And every dot is a resume, and the dot's green if that person was hired, and it's red if it wasn't hired. And you can see there was some discriminatory hiring going on because at equal levels of qualifications, the percent of male candidates was higher than the percent of female candidates. All right, so what's the model going to do? Well, here's a new resume with this amount of qualification where the dashed line is. And if this resume is from a man, then the nearest neighbors in the model are going to have been hired. So the model is going to score it higher. If it's from a female, the nearest neighbors in the model are going to have not been hired. So it's going to score lower purely because of that difference. And not to name names, but this actually happened. You know, it wasn't quite as simple of a model, but there was a pretty high profile situation where a big company got in trouble for this. And, you know, they didn't mean to do this. They just wanted to save their people time by getting rid of bad resumes, but that's misalignment. All right, so how do we go from such simple models to ChatGPT? Well, they're more similar than you would think, but let's back up and call out the major players or the people that got the ball rolling here. There's ChatGPT by OpenAI, there's Claude by Anthropic, there's Gemini by Google, Llama by Meta, Grok by X, Perplexity by Perplexity. You know, all of these have phone apps that people are using. I use them. They have APIs that you can build into your applications. And by now, there are tons of services like this that you can use through third parties that are hosting these models, charging you money to use them. And by the way, they are paying a lot of money to keep these models going. All right, so how do these models work at a basic level? And it's not as mysterious as you might think. They just predict the most likely next word over and over again. So they see some text, or they see a picture in a text, or the email that you've drafted halfway, and they predict the next word. And once they do that, they predict the next word. And once they do that, they predict the next word. And you can see where I'm going. And you do that 100 times, and now the model's written a paragraph. And that's what's happening when you go to your app and you see it start spitting out text. So when these companies train these models, they basically take every news article, every book on the planet, they train the model. So they say, here's the first half of this paragraph. What do you think the next word is? Oh, you got it wrong. It was this. All right. Now what do you think the next word is? Nope, it was this. And you do that, billions of times, and these models start to spit out text that sounds right. That's what they're learning to do. They're learning to sound right. It turns out that just sounding right isn't that useful. So these companies devised what is truly a brilliant approach to make them useful. It's called reinforcement learning from human feedback. So they ask the model a question, they have it spit out 4 different answers, and a human ranks those answers from most useful to least useful. And doing that works extraordinarily well. But there's an alignment problem, which is that being useful and being perceived as useful are actually not the same thing. So let's go back to alignment. The intended case is, let's train these models to be useful. But what's actually happening when you have human reviewers? These models are being taught to give answers that the human reviewer feels is useful. And humans feel something is useful if it makes them feel good. And that's why we have sycophantic models. So here's an article that OpenAI released acknowledging sycophancy in their own model. And they said, hey, we're working on this. Basically, and I've seen this when I use it, if you ask the model, hey, what should I do in this situation? This is how I'm feeling. And it'll answer the question. And then you open up a new chat and say, what should I do in this same situation? And you tell it you're feeling a different way. It might change its advice on what you should do to make you feel better. Why is that a big problem? Well, imagine what would happen if 2 opposing political parties each train their own model. Can you imagine how different the information coming out of those 2 models would be? And I'll tell you, it would be very different. And why is it different? Because the human reviewers who are teaching this model are going to rank an answer as more useful if they believe that it's true. So that's misalignment. I want to talk about data privacy for a second because I feel like data privacy has overshadowed misalignment. And it is a really valid and huge concern. There's this new idea that if I give information to a model, it's going to train on the information I'm giving it, essentially memorize that, and spit it back out to other users. And that has happened. So that's a real thing and a valid concern. However, these companies know how bad it looks if you give it personal information and it spits it back out to another user. So they're well aware of that, and they are working to make sure that that never happens. On top of that, they have privacy policies about how they use your information, and they typically have settings on whether or not they're allowed to collect it for that purpose. So where am I going with this? I just want to acknowledge that, while everybody's talking about data privacy with these models, we kind of forget about all of the intensely personal data we're saving in Google and Apple and password managers, which could all be leaked or hacked. It's pretty unlikely, but I also think it's unlikely or increasingly unlikely that your data gets leaked through these API model providers. So I think it's smart not to put overly personal information in there. I also think it's smart not to put overly personal information into your Google searches. I think that it's a good company policy not to let employees put protected company information into the models, maybe have an on-prem solution. It's a legitimate concern, but it's also not as new and as intrinsic to AI as this alignment problem. All right, so how smart is AI? Which model is the best? And it's a great question. There's not a straightforward answer. Here's a chat that I just made myself from Claude, where Claude said that 30 minutes plus 30 minutes plus 1 hour plus 30 minutes equals 3 hours, which is wrong. And it also implies that and a half plus 1.5 plus 3 plus a half is 8, which is also wrong. So here it's getting some really basic arithmetic very wrong. And we've all seen these models do dumb things. But we've also seen them do amazing things. So how smart are they? Well, it's really hard to answer that question. And people have made what are called benchmarks, which are basically 100-question, multiple choice quizzes on a certain topic or with a certain type of problem to test how smart a model is. So they'll make one for high school math questions. They'll make another for coding questions. They'll make another for tool use. So if it's a personal assistant with access to different systems, does it choose the right ones? And there are ones for solving puzzles. There's another for learning concepts and applying them. And what you see on these benchmarks is a model that does great on one thing might not even be on the leaderboard for another thing. So these benchmarks are great because they show us that models are better at certain tasks than they are at others. And they put a number to this question of how smart is it? Well, it gets this type of task correct about this percent of the time. What about this idea that AI models are developing some kind of intelligence similar to the human brain? We have 80 billion neurons. Each one's very simple. You put them all together and you get human intelligence. Kind of like how in a flock of birds, each bird's just trying to follow the other one, but you get these crazy looking shapes that a bird couldn't possibly conceive of. Because these models were taught to sound right by predicting the next word, and I still see them do something like 2 plus 2 equals 3.5, I tend to see them like the math student who got an A by memorizing every possible formula and type of question without actually understanding any concepts. But there's an argument to be made that if they score well enough on hard enough questions, then maybe that means that some kind of intelligence is emerging from the massive scale of these things. It feels to me like a lot of these companies are betting that if they just keep scaling up the GPU server farms, that these models will develop some sort of intelligence. I think that's possible, but I don't think that it's a given. I think plenty of people argue that because of the performance we already see from these models, that they already have intelligence. But there's a lot more to AI than just ChatGPT. That's just a type of model. There are other classes of models that are entirely different, like reinforcement learning, where you might think of a computer that plays chess or a self-driving car. So in these models, there's a state of something like the surroundings or a chessboard, and there are actions that you can take, pressing the gas, the brake, or moving a chess piece. And the model chooses the action that's going to achieve the most desirable state. And the most desirable state is a function of all of the states that have been observed in the past. Now, to be honest, there's a lot more that goes into self-driving cars than that. There are different systems working together, but that doesn't change the point. Then there's diffusion, which again is its own category of model. And you see this with AlphaFold, which predicts how a protein is going to fold. Now, I'm not a biologist, but I'll say that this model has taken a process that took researchers days or weeks to figure out if their protein design worked and cut it down to a few hours. And these people are designing proteins to attack cancer cells and stuff like that. And then there are all sorts of little simple automations. Like my dad said that he has 10,000 digitized images that he'll never go through, but he wishes he could find the 10% of them of his kids from when they were younger. And an AI model that used facial recognition to do that task with any sort of accuracy would be really useful, because right now he has nothing. He would have a filtered album of mostly his kids. There might be some of other people's kids in there, and there would also be pictures that the AI missed, but on the whole, it would be a very useful thing. Every single AI system that has ever been built and ever will is going to make mistakes. It's going to do things that seem dumb. Some percent of the time, it is going to fail catastrophically. So here's an overly simplistic framework for when AI can be helpful. If error cost is very high and you want full automation, this would be self-driving. then you need the AI to be at least as good as the human. That's a good rule of thumb. If the errors don't matter, like my dad's picture filtering example, then you can just automate it and accept the error, and it's still useful. Most of the time, errors are not acceptable, and human level performance is not possible. So you go with human reviewed, where the model can make the task faster, but a human can check the work to make sure it's right and easily catch errors. You can also mix full automation with human review. So here's a case study my company did where we helped a company automatically purchase invoices if it scored above 99%, essentially, and everything else went to a human reviewer. And when I say 99%, I mean a model looked at an invoice and said, there's a 99% chance that this thing is safe to buy. So how dangerous is AI? I think when people ask this, they're probably talking about this idea that AI is going to get smarter than people and take over the world. Not that that question isn't reasonable, but to me, the more immediate fears are one, deepfakes, because we can make them today. So essentially a family member or a world leader saying something in a video that they actually didn't say in real life. It's a fake video. That's very scary. And then we've shown at the beginning that if you don't have the right guardrails on these models, then they can be extremely harmful depending on what you're using them for. I mean, think about this. What if a health insurance company decided to use a model to predict if a claim is valid and should be accepted? And let's say they automatically accept claims above a certain score. All right. Well, what if instead of doing that, they use the same model, but they automatically reject claims below a certain score? So what about job replacement? I mean, what's going to happen to Uber and Lyft drivers if everybody prefers Waymo? I don't know. But in a virtual world with a technology this powerful, I have to imagine things will get shaken up. At the current level of intelligence, I find that these models are usually better at really obvious, kind of mundane tasks that the human usually doesn't want to do and would rather manage someone else doing. So it might reduce the demand for certain jobs. I think it might help humans with experience in a certain job take a step back, work at a higher level, get more done in the same amount of time by getting the AI's help with the parts of their job that they find boring and be more of a manager, essentially. But even that might be kind of a pipe dream. It's hard to say what'll happen, but something's going to happen. I think part of this question hinges on how smart is AI going to get? And we've already talked about that, and that's a whole topic for debate. But don't forget, to know how smart an AI is at something, you have to define the task and measure its performance. And then finally, artificial general intelligence. I think this started as the idea that AI would get as smart as humans, and we kind of realized, well, we don't really know how to define what intelligence is, even for humans. And at the end of the day, it's apples and oranges, because humans are unique biological organisms with an evolved brain and all these emotions, and a computer is a machine-produced thing that's identical to every other computer just like it. It doesn't have a brainstem that gives it a fight or flight response. It's just a different thing, even though we compare them so much. And then finally, it's hard to say if computers will achieve AGI if we don't have a consistent definition of AGI. So if I'm going to leave you with anything, I'd like to leave you with this. If you want to use AI in your business, have it perform a specific, well-defined task, record and measure everything it does in as many ways as you can think of, and just know some percent of the time it's going to screw up huge. So you have to have guardrails in place to handle that. That's it.